This is a trigonometric function that I'm asking you to solve for theta. You have to remember the basic trigonometric identities in order to solve this. Just as a reminder, you have sine squared theta plus cos squared theta is identical to 1. You also have sine theta divided by cosine theta is identical to tan theta. You may use one or the other or both, but I want you to pause the video and go ahead with this. Okay, you finished? Now, let us see what's going to happen here. We have 4 cos squared theta minus 8 sine theta plus 1 equals 0. How do you deal with this thing to get theta? Let's see something here. Now, this 4 cos squared theta. And you have sine theta. If you had 4 something square minus 8, the same thing, plus 1, then it would be the case that you would have a quadratic equation, because it would be like 4x squared minus 8x plus 1 equals 0. You see that? The problem is that you cannot have x being the same as cos squared theta and the same x as sine theta. What you need to do is to have the same unknown throughout. Make both of them sine squared theta or sine theta. Make both of them sine theta or both of them cos theta. It seems it might be more convenient to rewrite the cos squared as sine. Now look at this cos squared theta. Let's transpose for it. Cos squared theta is identical to 1 minus sine squared theta. Alright. So you could rewrite this cos squared theta like this. So you have a number 1 and cos squared and sine squared theta. So let's do that. 4 cos squared theta, but cos squared theta now becomes 1 minus sine squared theta. See that? Minus, and you have the 8 sine theta plus 1 equals 0. Alright. Now what will happen after? You multiply the bracket by 4. So you have 4 minus 4 sine squared theta minus 8 sine theta plus 1 equals 0. Alright, let us fix it up so that we have a number sine squared theta plus a number sine theta plus a number. Alright, so this is negative 4 sine squared theta. So we have a number sine squared theta minus 8 sine theta. So we have a number sine theta plus a number. You add the 4 to the 1 here plus 5 equals 0. Alright. With the negatives, kind of a bit more stressful to have the negative in front of the 4 and so on. Let's multiply it through it by negative 1 to get a positive 4 sine squared theta. So we have 4 sine squared theta plus 8 sine theta minus 5 equals 0. Alright. Let's get this circle out of the way. So now, let sine theta be equal to x. So we can write this This is now a quadratic equation in sine theta, you know. We want to write it as a quadratic equation in x. It would be a lot easier to solve and less confusing if we just have one letter x instead of sine theta. Alright, so you have 4x squared plus 8x minus 5 equals 0. Alright. Now, let's see. Could we solve this by factorization? Let's see something here. AC method, 4 by negative 5 is negative 20. Which two numbers multiply to give a negative 20 and add to give a positive 8? 4 and 5 won't work. 10, 2. I think of 10 and 2. Alright, if we have a positive 10 and a negative 2, 10 times negative 2 gives a negative 20. 10 plus negative 2 gives a 8. So those two numbers will work. So at one end we have 4x squared. At the other end we have minus 5 equals 0. But in the middle we divide up the 8x into 10x and negative 2x. So plus 10x minus 2x. Then we factorize here. We have 2x outside the bracket. 2 into 4, 2. X plus 2 into 10, 5. Alright. Minus 1. Then we have 2x plus 5 equals 0. See that? We factorize. So, the 2x plus 5 is a common factor. We have 2x plus 5. 2x minus 1 equals 0. Alright, so in solving this, remember the argument here is that these two things multiply and give you 0. So either one of them is 0 or the other is 0. Maybe 2x plus 5 is 0. Or maybe 2x minus 1 is 0. Or maybe both of them are 0. Because 0 times 0 gives you 0. 0 by anything gives you 0. So in this case, x would be negative 5 over 2. Now, in this case, x would be half. What was x again? X was sine theta. So, sine theta equal negative 5 over 2. Well, this would be greater than 1, you know, because negative 5 over 2 is the same as negative 25 over 2 times. 1. But this cannot work because the sign doesn't go above 1 and doesn't go below negative 1. So this is out. Sine theta equals half. Alright, this could work. The sine of theta equals half. Now, which angle is such that when you find the sine of it, you get half? Let's see something here. Unit circle. Oh my. Want to see how the unit circle goes. Now, we have a triangle here. Let me draw the triangle properly. We have a certain triangle here. The opposite over the hypotenuse is half. First of all, if sine theta is half, then theta is equal to sine inverse of a half, which is equal to, so it's going to be 30, because 30 degrees. Or if you're working in radians, you would put your calculator in radian mode. I don't see any way to put my calculator here in radian mode. But anyway, we find the inverse sine of 0.5 gives us 30 degrees. So 30 degrees. So this angle is 30 degrees. Which other angle does it work? Sine is opposite over hypotenuse. Now you can see the opposite goes from 0 up, not down. There's a positive opposite over a positive hypotenuse. Now, which other quadrant does it happen again? It's in the second quadrant, right? So, if we consider here, this angle, you know, is 30. But that's not that angle that we're really looking for. The angle is measured from 0 in an anti-clockwise direction. So, this angle is 30. But the other angle we're looking at is this, which is 180 minus 30. So call this theta 1. Theta 2 would be 180 minus 30, which is 150 degrees. Remember, the sine of theta is half. So I expect to get the sine of 150 to be a half. Let's see how it's going to work out. The sine of 150 equal half. It is half. Right? So, therefore, these are the two angles. If you're limited to between 0 and 360, then these are the two angles that gives you half when you find your sine. Sine 30 and sine 150. So that's the answer to our question up here. I didn't specify between 0 and 360, right? Generally, it's between 0 and 360 degrees. So, what we have, answer, theta is 30 degrees, and theta is 150 degrees. Those are the two angles. When you find the sine of them, you get a half.